quizzes, but I don't want you to. All right, we really do need to start looking at what we did on today's quiz and so on and so forth. I also thought that today's quiz was pretty challenging, and I thought that we did a nice job solving number 2. Even the people who got it wrong almost completely got it right. Lots of people got it right. We got beat up on number 3. And I think the reason we got beat up on number 3 is because I haven't done too many questions like that. But once I show you what they were actually asking, I don't think you will look at it as difficult at all. I think you'll say to yourself, oh my God, what an easy question. It just has to do with your interpretation of number 2. So, without any further ado, let's take a look at number 1 here. Number 1 talks about which ones represent functions. Okay, which ones are going to represent functions? And the thing you have to remember about a function, guys, every input has to have a unique output. You can never have one input that has more than one output. If that's the case, it's not a function. So, if we take a look at number 1, what I see here is a 2, a 3, a 4, a 5, and then another 2, which means if the input's 2, the output's 6. And if the input's 2, the output's -6. That can't happen. So this is not a function. Okay? Now I look at this one, and if for choice 3 here, we do a thing called the vertical line test, which means if I draw a vertical line, it has to hit the graph no more than one time. Only once and only once in every place. If I draw this vertical line, clearly I touch twice, which means let's just say this was where x is 3. Then it would be, up here would be, I don't know, whatever, 3, 4, and down here would be 3, -4. So it's one input with 2 different outputs. So clearly, that's not a function either. Vertical line test is something most kids remember all the time, and I think you did it really well on your quiz. Now, if I look here, it says, I'm just looking for my input values. I don't care about output. 1, 2, 3, 4, 5, 6, 7. They're all unique, which means, Allie, that every single one of the inputs has its own unique output. So 2 is a function. That's good. And if I take a look at number 4, is there anything here that would cause this to not be a function? No, this is fine because that does say 1 y equals, right? Mm-hmm. So that would just be you double the input and add 1, so there's no problems there. So what you're going to need is, in this case, 2 and 4 are the 2 that would be functions. Okay? All right. I liked that question. I thought it was very difficult. And not so much that it's a very difficult question in the grand scheme of life, but it's difficult in the sense that I've never seen them ask a function question that was that hard. Usually the function question is like a piece of cake. It's so easy. They just do 4 graphs and they say which one's not a function. And you just draw the vertical line test 4 times and you see which one fails the vertical line test. This one put all the different possible combinations up there to see if you could figure it out. Okay, next. As I watched you guys or looked at your work here, you looked very good. I'm going to go pretty quickly here, and then at the end you can ask if you have any questions. Distributing the -3, 7x minus 12x plus 24 is less than, is that less than or equal to? Less than or equal to. 6x and -9x is -3x plus 12. Then over here, this will become -5x plus 24 is less than or equal to -3x plus 12. Now you have a choice to make when you do this inequality. It's so traditional in inequalities to get the variable on the left. You really want that to happen. But the problem is that if I do that, I'm going to end up with negative x's. I'm going to choose to do it anyway. Add 3x to both sides. If you added 5x to both sides, it still works out. You're just going to need an extra manipulation at the end. So this gives me 2x, and I'm trying to save space here, so I'm going to do the -24 in the same spot. Is less than or equal to -12. Then I divide by 2.
It's -2.
Oh, the -2, I'm sorry. And then I'm going to get, and remember, when you divide by a negative, you've got to switch the sign. X is greater than or equal to 6. A number of people put x is less than or equal to 6. If you did, I took 10, I graded this one out of 60. So if it was more right, nobody had more wrong than right. If it was more right than wrong, but you didn't get it perfect, I gave you 40 out of 60, 2 out of 3, which is the norm for the course. And if you just messed up the sign, I only took off 10 points. A lot of people got it completely right. Okay? Now, remember that the answer is x is greater than or equal to 6. Okay. Here's the thing. X is greater than or equal to 6. And then it gives us this interval. And this is the question that really cost people hundreds. Or 90s. Over the interval from 4 to 8, it says here, state all integers. Integers are whole numbers, positive and negative. But they only want us to limit the interval from 4 to 8, include the 4 and include the 8 because it's staples. Which ones satisfy this? Well, it says specifically it wants the ones that are greater than or equal to 6. So the answers are 6, 7, and 8.
Part of number 2.
Yeah, I didn't know.
Yeah, because it said integral values or integers. See, in here it includes all the fractions, the decimals, the irrational numbers.
Yeah, I thought it was different.
Right, exactly, and I think that's exactly what went on with most people in the room. I don't know if anybody knew how to correctly interpret this.
I was close.
Okay. There you go. So what I wanted to do, when I made up this quiz, every time I look and make up a quiz, what I say to myself is, what did I cover? What did I teach? They should be able to do the bulk of it, but is there something in there that they might mess up that we didn't hit well enough? And when I looked at it, I thought we didn't hit the last one well enough. But I thought by going over it this time, it would make a lot more sense to you. And then when we take the quiz tomorrow and the next day, you'll get a chance to refine it. So understand again, this means the interval from 4 to 8, and it's all the numbers. It's fractions, decimals, integers, etc. Which ones satisfy this answer, that x is greater than or equal to 6? So the answer is 6, 7, and 8. What if it would have said x is less than 6? What would the answers be then?
4, 5, 6.
Just 4 and 5, because I only said less than. If I said less than or equal to, then it would be 4, 5, 6. Okay? What's that?
It's the same question.
Yeah, it's based on this answer.
Oh, we didn't know.
So like if you, listen, hold on, excuse me. Just so you know, let's just say you had this answer, x is less than 5. Then down here, I would have looked for a 4. So it was based on whatever you put here. If you had an answer that said x was greater than 18, which I think maybe one or two of you did, x was greater than or equal to 18, then down here I would have wanted to see no answer. Or we talked about the empty set a while back. Okay, because there is no answer here from 4 to 8 that's greater than 18, or greater than or equal to 18. All right, so it's based on whatever you get for your inequality. I then looked for something that matched your inequality here. Okay? All right, so now let us take a look at today's sheet, today's do it. What did you guys get for the first question? What do we get for the first question?
No.
9?
Yes.
You got yes.
I got no.
I got yes.
No. You don't have the same one.
Oh, you don't have the same one?
Ours is like. No, his is down a little bit. No, it's still not the same thing.
And this is 44, and you said yours says
Just
44,
the first
right?
question.
Just the first question, the rest is okay? Okay, I'm going to explain the first question very quickly. Mariah thinks the following rule should always hold true. Does it? No, it definitely doesn't. If you do double distribute, you'll get a squared plus 2ab plus b squared. Okay? If you do a plus b squared, guys, listen very quickly. If you do a plus b squared, that means multiply a plus b times itself. And when you do double distribute, you come out with a squared plus 2ab plus b squared. Okay? It never equals that. Okay? All right. So now we got to talk about John and his fishing company. And this leads us into the word problems that we'll continue with today's lesson. John makes lures for a fishing company. Over 2 days, he makes 71 lures. First day, he spends much of his time preparing for the job. Second day, he makes 9 less than 3 times the number he makes on the first day. So the minute I read a question like this, I always like to turn around and write first day, second day. I really like it to be organized so that I can follow what's going along. Okay? So I'm going to let D be the first day. And the next day it says he makes 9 less than 3 times the number on the first day. So that would be 3D minus 9. Now, I call this like the setup. if you're gonna, I remember when I was changing a tire for the the very first time it was actually on the road. But I remember one time changing a tire in my driveway at my parents' house. And I'm changing this tire, and my dad, he walks by me changing the tire, and he just shakes his head and starts laughing. And I said, "What is so funny?"
Throw it upside down.
He goes, no, you can't put a tire on upside
I
down.
mean, like,
No. So anyway, no, as I was taking all the pieces off, like, you crack down, you get the lug nuts off. They just spread all over the lawn. He goes, do you know how much harder it's going to be to find all those pieces when you're done? He said, when people change tires, they pop the hubcap off, they lay the hubcap down. Then they take all the lug nuts and they put them in the hubcap. Then they take the tire off and they put that down. And he goes through the whole thing and he says, everything is neat, everything is organized. It makes your job so much easier in the end. And he was right, because I wound up hunting all over the place for these lug nuts in the lawn. And
maybe you should make your desk.
Yeah.
we're gonna get the desk back to clean. I have to give back all the tests. When all the tests are back, then we'll be in good shape. She gave me the look, you see. All right, so now, all together, they make 71 lures. So if I add these 2 days up, that would give me 4D minus 9 is 71. And then once I get to here, it's really easy. Now, I just want to pause for a second. Did any of your papers have 3D minus 9 equals 71? See, if you did, I think the biggest problem, that the reason you had that is because you didn't do first day, second day. You went right to 3D minus 9 because you saw the stuff in here about 9 less than 3 times. But don't ignore over 2 days. Whenever the problem says one number and another number over 2 days, you always want to take the time to do this setup right here. And that will stop you from making that mistake. So 4D is 80, dividing by 4D is 20, and I get 20, and it wants how many's on the second day? That would be 51. Okay? Any questions? All right. So I don't know if any of you fish very often, but if you fish very often, you'll know fishing equipment is called tackle. And in my sick, demented, warped sense of humor, it is time to tackle. That's funny. It is funny. Maybe not on a Monday morning, but it's funny. Okay. Now. Right. There you go. All right. It's time to tackle one of the algebra problems that often frustrate students. We're going to spend many... Guys, we're going to spend many days doing this. So this is just the beginning of our understanding. Lisa bought half her savings to the bakery and bought 12 donuts for $14.20. The amount of money she brings home with her is more than $2. Use an inequality to show how much money she had in her savings before going to the bakery. Okay. Now, if we let X be the amount of money in her savings, then she brought half of her savings to the bakery. So half of her savings is X over 2. Agree? Yes. All right. The amount of money she brings home with her is more than $2. So X over 2, using how much money she has saved before going to the bakery. All right. The amount of money she had, she took half of her savings to the bakery and bought 12 croissants for $14.20. I really don't care that she bought 12 croissants. What I do care is that they cost a total of $14.20. Okay? Now, the amount of money she brings home with her is more than $2. So if I was, let's just treat this as an equality for a moment. I would multiply both sides by 2, and I would get X is 28.40. Agree? Now, what's that? All right, so we have 28.40, but it says here, this is the confusing part. It says the amount of money she brings home with her is more than $2. Okay, so use an inequality to find how much money she had in her savings before going to the bakery.
Wait, so that means when she went to the bakery, she had 20, more than or equal to
Yes, what she's saying, what we have saying is this, Ivy is saying that, since it's 1420 here, that means that she has $2, she has more than $2 when she brings home with her is more than $2. So that X over 2, then if it's gotta be greater than or equal to 1420. And what she did was she said, okay, since she has more than $2 to bring home with her, that means it had to be greater than or equal to 1620, because it's 1420 for the croissants, and then it's $2.20 here. So now the question is, use an inequality, which we did. We multiply both sides, and I get X is greater than or equal to 3240, okay? And I'm multiplying both sides by 2. Okay? Times by 2. But what does the question ask here? Use an inequality to, okay, so I did use an inequality. My inequality, I know this is a little confusing. Here's my inequality. They didn't actually ask me to solve it. We'll get to that tomorrow. Hasta la vista. Vaya con Dios. Peru. Ta-ta. Arrivederci. Smile a lot. Ciao. Arriv Zane. Adios amigos y amigas. Cheerio.
Please, Evan Rivera.